So following on from the previous video, we got to a stage where we worked out our inflection points here, and now in this video we can use the second derivative to double check all our work. So now we just bear in mind that when f double prime is less than when f double prime is less than 0, then you will have concave down. So the original function should concave down. When f double prime is greater than 0, you have concave up. So the original function would concave up. So now we can use our second derivative to double check everything. Okay, so looking at this now, now let's just check in the region between 0 and 1. So in this region here. So our second derivative should concave down, looking at this graph. So let's double check everything. So looking at our second derivative, looking at the second derivative. So now we are, hang on, let me just move this across. Now we are, hang on. So looking at our second derivative here, we are going to use this to double check all our work before. So looking at the range between 0 and 1 here, that's this region here. Looking at this region here, okay. So now looking at that region there, looking at that region here, look at this now. This is our second derivative. F double prime equals this thing here. Now in this region here, in this region between 0 and 1, you've got 2 take away. Now the natural log within this region here, if you look at the natural log of x, if you look at the graph of the natural log of x here, in this region here between 0 and 1, that's between 0 and 1 here, the natural log of x will be in the negative realm. It will be a negative number. Okay, so looking at this, hang on. So looking at our double prime here, in the case of x being between 0 and 1, this natural log here is going to be a negative number. So here you've got a 2 take away a negative number. Now 2 take away a negative number is going to be a positive number. Okay, so hang on. So hang on. Let's start again. Looking at f of double prime is this. Now in this region here, 2 take away this. Well, this thing here will be a negative number here. It will be a negative number. And then looking at this here, this here will be a negative number. So this bubble here will be a negative number here. So later on we've got to cube our negative number. Okay. So this thing here in this region, it will become this. So this point here is negative. This here is negative. Okay. So so we are currently here. So now when you get 2 take away a negative number, the answer, the top part here, will be a positive number. Okay. So now when you have a negative number and then you cube it, it will be a negative number, because negative, for example, negative 2 times negative 2 times negative 2, the overall answer will be a negative number. Now a negative number, so this bit here will be a negative number. Don't forget x is a positive, because x is in the region of in between 0 and 1. So this x here is a positive times, remember this thing here is overall it will be a negative. So this whole thing here will be a negative number. So f double prime will be in this region here, it will be a positive number divided by a negative number. So that will be a negative number. So overall this whole thing here will be a negative number. So what we've established is that f double prime will be a negative number in that region. So that means our graph should concave down. Okay, so looking at our original graph here, it does indeed concave down. So we can use f double prime to check our original work. So it makes sense in this region. Now let's double check in this region now between 1 and e. So hang on. So in between 1 and e, it would be, hang on, in between 1 and e, it would be this. Hang on, let me get rid of the old one. Now, hang on, let me move this. Bear with me. So bear with me. Yeah. So now we are going to look at f double prime in this region here. Okay. So in this region here. So in this region here. Remember, we are looking at it in this region here between 1 and e. Okay, so looking at, don't forget, between 1 and e, the natural log will be a positive number. Between when you natural log a number between here, it will give you a positive number between 0 and 1. Bear that in mind. Okay, so hang on, let's start again. So now looking at f double prime in this region here. So in this region, you've got 2 here, take away, and then this thing here will be in between the number. This thing here will be a number in between 0 and 1. Okay, so you've got 2 take away a number that's between 0 and 1. Okay, don't forget, 2 take away a number between 0 and 1. This thing here will be a positive number. Okay. Now looking at this thing here, hang on. Currently we are at f double prime. In this region here, the natural log here will be in between 0 and 1. Because if you look at this here, if you look at the graph in this region here, this is the natural log. When you natural log a number in between these two, it will give you a number between 0 and 1. So what that means is looking at this thing here will be a number between 0 and 1. Well, a number between 0 and 1 is a positive number. So here you've got a positive number. So basically this whole thing here becomes this thing here. Okay? So when you have a positive number, then you cube it, it will remain a positive number. And then you times another positive number. So overall this thing here will be a positive number. Now up here you've got 2 take away a number that's between 0 and 1, so it will remain a positive number. So f double prime is a positive number. Okay, that means it will concave up. Okay, so looking at our graph here, it does indeed concave up. Okay, now use the same argument for a number between here and here. So hang on. So now let me get rid of the old one, and now let's consider the region. Oops, hang on. Bear with me. Okay, so now hang on. So now we're looking at f double prime here in the region of in between here and here. Okay, we are now going to look at this region here. So f double prime in that region. Okay, so when you look at the graph here in that region, the graph will look like this. This is the natural log of x. So in this region here, hang on, let's start again. Sorry, bear with me. So f double prime here. Now let's consider it in this region here. So in this region here, this thing here will be between 1 and 2. So this natural log here, in this region, it will be between 1 and 2. Because if you look at the graph here, in this region here, it will be between 1 and 2. Okay, so use the same argument here. So this thing here will become this thing, and then overall f double prime will be positive, meaning it should concave up. Okay, so looking back at our graph, it does indeed concave up. Okay, and now use the same argument for the region e squared towards infinity. So let me get rid of the old one. Now in this region here, so hang on. So consider f double prime here in this region here. Okay, so don't forget, in this region here, the natural log of x will be greater than 2. Okay, bear that in mind. So let's start again. F double prime is here in this region. So you've got 2. Take away this number here. Don't forget, this number here will be bigger than 2. So now you've got 2, take away a number that's bigger than 2. That will give you a negative number. That will give you this negative number. And then blah, 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 same argument. F double prime will be a negative, meaning it will concave down. So looking back at our original graph, it does indeed concave down. Okay, so we can use F double prime to double check our work. Okay.